Dance consists of movements of the body interspersed with motionless poses. Often, these poses in the spectrum of leaps, turns, and lifts demonstrate balance of the body over a small area of support on the floor. This balance exists if and only if the center of gravity lies on a vertical line passing through the area of support at the floor. If the dancer is motionless, the sum of all the forces and torques acting in the body must be zero. The force of gravity vertically downward would be balanced by the force upward from the floor to the foot, which is the normal force, acting on the same vertical line. This concept is derived from Newton's third law of motion, which states that whenever one body exerts a force on a second body, the second body exerts an oppositely directed force of equal magnitude on the first body. If the center of gravity is not in line with these other equilibrium state forces, the dancer will be unbalanced and experience an angular acceleration towards the ground and fall to one side. In reality, if the center of gravity is close to the balance area, that is, if the forces are almost but not perfectly vertical, the acceleration away from vertical is initially quite small and the dancer appears to be balanced. The pirouette is the rotation where the dancer supports herself on one leg while the other leg is in passe. A pirouette must begin with some form of a preparation position followed by a torque exerted against the floor. The torque of the floor against the dancer causes the angular acceleration that produces turning motion. Torque is equal to the force multiplied by the distance of the lever arm. The torque to initiate a turn can be exerted against the floor by 2 feet with some distance L. The forte turn involves many physics principles acting at once. The dancer pushes off the floor to produce torque. With each turn, her momentum is lost due to friction. When the dancer's foot flattens and rises again, new torque is generated. At the same time, her arms open to help her balance. Also at the same time, her leg extends out, which is storing some of the momentum of the turn. When the leg comes back in, some of the momentum is transferred back to the dancer's body, which propels her around. Another factor in turns is the dancer's moment of inertia. The moment of inertia depends on the mass of a body and its distribution relative to the axis of rotation. A body of given mass will have a larger moment of inertia if the mass is far from the axis of rotation than if it is close. One last powerful concept for dance analysis involves angular momentum. It is the conserved quantity and is constant if there are no other torques acting on a body. There is no way that changes in body position alone can change the total magnitude of angular momentum. Once the initial torque against the floor has been exerted, angular momentum is conserved. Chemical adhesion and roughness contribute to a frictional force that acts in a direction tangential to the interface between the surfaces. Each type of surface has its own coefficient of friction. This coefficient of friction, multiplied by the normal force, which is the vertical force perpendicular to the floor, will give the force of friction which acts against the motion of the dancer. Many dance movements involve sliding on the floor or rotating against it. Whether a dancer needs a change in linear horizontal motion or an angular acceleration, the floor must be able to supply the horizontal force that provides for such accelerations. Because gravity acts vertically downward on our bodies at all times, we can only remain motionless if there is the vertical supporting force equal to our weight. In order to jump off the ground, we need to exert a force downward against the floor greater than our weight for long enough to achieve the vertical upward velocity desired. Jumps begin with a bending of the knees to obtain enough force and have projectile motion. Once the body loses contact with the floor, the center of gravity will follow a parabolic trajectory that is totally determined by the initial conditions starting on the ground. The trajectory will begin with initial velocity, which will decrease as the dancer rises into the air until it reaches 0. This is at the maximum height during the leap. Following this maximum is the descent to the floor. Although dance and physics are completely different topics, this perfect combination of art and science show how interdependent and connected these subjects are.